Here we're going to come to simplifying algebraic fractions, and as with all of algebra really, it's a build up on what you did last year. So in the past, when you had algebraic fractions with the denominator and the numerator had only one term, then you cancelled out any common terms. 6 divided by 2 is 3, the x at the bottom cancels x at the top, and the answer is 3x. This year, I won't give you ones like that, except as working inside other questions. What they'll expect you to do for achieved is to simplify ones with multiple terms on top and or bottom. So we have one like that, and we have to be able to quickly and efficiently simplify that to 3x plus 5. So how do we go about doing that? Well, this is the rule. You can only cancel out common multiplication terms. You can't just cancel out something that looks like something on the top line. You've got to have it as a multiplier, and that means you have to factorize it first. So we look at that. Now there's no way we can cancel that x with that x, because that leaves that unaffected. It's not possible. 3x is dividing both x squared and x. So instead of racing off and doing something stupid like that, we factorize it, and then we see that we have a common factor, top and bottom, the x, and they cancel out, and our answer is x plus 1 all over 3. Another simple one, here we have this. We can't just go around dividing the 16 by the 4x and think, oh, well, that doesn't work, so we'll just cancel the 8x and the 4. That's nonsense. The 4x is still dividing the 16. It can't be cancelled without cancelling both. We factorize, we take the common factor of 4 out of both of them, and our solution would be, with the 4's cancelled out, 2x plus 8 over x. Don't attempt to do it by any other way than factorization. It's always wrong. So, how do we do it? We take one of these, pretty standard is what we get, and we notice that the top term is quadratic. So we factorize it as if it's a quadratic. We get our calculator out, and in equations, polynomial, degree 2, we type in our factors, which are 4 minus 49 and 12. 4 minus 49, 12. We find our solutions 12 and a quarter, and they're going to be our factors. So we take that, and it's 4, still got the leading 4, minus a quarter, minus 12. And we notice at that point that the minus 12 and the minus 12 are the same, so they cancel out. That's why it's always going to be. There is always going to be a common factor. You've just got to find it. That leaves us with this, which is the form they like. They like the 4 multiplied in, and so that's our answer, 4x minus 1. Do another one. This time we notice the quadratic is on the bottom. So we factorize the bottom using our calculator, and I'm not going to do it, but it'll give you the solutions at minus 2.5 plus 0.75, and obviously it's the reverse. Then we're going to multiply the 8 in, the 2 cancels that bit out, 4 cancels the fractional bit of that, and we end up with 8x plus 12x minus 15 is 2x plus 5, 4x minus 3, and miracle of miracles, the 4x minus 3 is common to top and bottom. So that cancels out, and we're left with not 2x plus 5, because the 2x plus 5 is on the bottom line. 4x plus 3, when it cancels out, becomes 1 over 2x plus 5. If the remaining term is on the bottom line, it's got to stay on the bottom line, just like always. And one more time. Now, this looks like the other ones, but in fact, there's a bit more to it, because not every factorization is going to be a quadratic. We actually find that the top quadratic is very simple. It's actually divided all by 2, becomes x squared minus 7x plus 12. So it's all 2, x minus 4, x minus 3. When we look at that and we think, hang on, I factorise top and bottom, and that's not cancelling out. Now there's something happening there. So we look for a common factor, and we see that in fact the bottom line can factorise without being a quadratic. We can take the 8 out of that, and we get 8 times x minus 3. And surprise, surprise, we have a common factor to cancel out, and that gives us our answer. Except of course it doesn't, because 2 and 8 still have a common multiplication factor. So 8 is 2 times 4, and we can cancel that out. And that leaves us our answer, the x minus 4 on the top divided by the 4 that's left on the bottom. So beware, not every factorisation is a quadratic, and you've still got common terms to cancel out as well. And that gives us our method. We only cancel out common multiplication terms, which means you have to factorise. You have to make everything, instead of being plus and minus terms, be multiplication terms. Then you cancel any common factors, which may include common numbers and factorisations that aren't quadratic.